Hi, and welcome to this lecture on the topology of aircraft and spacecraft structures. When you sit in an aircraft, or if you're very lucky a spacecraft, it feels as if you're inside a thick tube. However, all is not quite as it seems. Let me show you. If you look at the photo of the cockpit on the left, it appears as if the aircraft wall is quite thick. However, if we strip away all the equipment, you can see that the actual skeleton of the aircraft is really quite slender and thin. What you see in the second picture here is what we call an airframe. That is an aircraft or spacecraft without installed equipment and furnishings, just its bare structural skin and bones. So, what are the main functions of an airframe? They are threefold. First of all, they have a load-bearing function. The airframe takes up the forces during flight, takeoff and landing, and when making maneuvers. Secondly, the skin and framework, which you could see as a skeleton, also provides the aerodynamic shape needed to generate lift. Finally, at least nowadays, the airframe also provides those inside with protection from the environment. This was of course not always the case. If we look at this drawing of the first Dutch aircraft to fly, the Fokker Spin or Spider, you can see that sheltering the pilots from the environment wasn't a priority in the early days of flying. But things have come a long way since then. If we look at the F-16 Fighting Falcon, we can see that the pilot is fully encased. Sometimes it is difficult to say whether an item is part of the airframe or not. Let's take a look at the Space Shuttle. Do the ceramic tiles that protect the occupants from the heat at re-entry belong to the airframe or not? You could argue yes, as they shield the astronauts. However, they have no load-bearing function, so based on that criterion, they are not part of the airframe. When we look at the airframe, we can divide the airframe into a primary and a secondary structure. The primary structure of an aircraft is formed by those parts of the aircraft or spacecraft that in case of severe damage will cause the entire aircraft to fail. Think here of the fuselage, the wing, or the empennage, that is the tail of the aircraft, consisting of a horizontal and vertical tailplane. Secondary structures are elements of aircraft or spacecraft that carry only aerodynamic or inertia loads, generated on or in the secondary structure. Here, you can think of the control surfaces of an aircraft. To create this airframe or skeleton, it is built up out of a number of structural elements. And, as we'll be using these terms a lot, it is important that you familiarize yourself with the terminology. Let me start with the topology of an aircraft fuselage. It generally consists of the skin, which forms the outside of the fuselage. This is reinforced on the inside with frames. They are the circular arches you can see. Its longitudinal shape is kept by stringers, and those are the thin parallel beams in between the frames. To ensure the aircraft can be pressurized, the fuselage also has a bulkhead, which is a solid frame just below the cockpit windows. Finally, there are the splices, which are the connections that perform the total load transfer between two structural elements. The topology of a wing consists of the wing skin panels forming the outer shape, the ribs that maintain the aerodynamic shape and that can be used to introduce loads into the wing, and the spar that keeps the wing from bending. Finally, the assembly of spars and skin that together form a coherent whole that resists the torsion and twisting of the wing. Hopefully, this will give you some basic understanding of how aircraft and spacecraft structures are built up.